Okay, this is on page 257. Solving quadratic equations using factoring. We've been doing a lot of factoring. So far it's just been a skill. Now we're going to see why we're teaching you to do this. What can you do with it? We've also been working with quadratic equations. I don't know if you know this or not. That's a quadratic equation. Something with a square. It makes a parabola shape. We'll get to this chapter later on. Investigating the zero product law. Okay, what is anything times zero? It's zero. I don't care what x is. This statement is true if x is what? What does this have to be for this to work? 3. If you see it, great. If you don't, then we need to solve this thing. Okay, add 3 to both sides. X is 3. Okay, that's the solution. This is true if x is 3. All of these you're going to want to ask yourself, okay, what must x be for this equation, in bad English, to work? That's what you want to ask yourself. What does x need to be here for this to work? -1. Okay, let's put these both together. If this is 0, I don't care what this is. When I multiply by 0, it's equal to 0. So, if this is 0, what must x be? 3. Likewise, if this is 0, I don't care what's in these brackets. Anything times 0 is 0. So what does x need to be here for this to be 0? -1. So we have two choices here. For this value of x, what must it be for the whole thing to be 0? Well, if x is 0, then I don't care what this is, it's going to be 0. Look at inside the brackets. If this is equal to 0, I don't care what this is, anything times 0 is 0. For x to be 0 here, it needs to be -1. Okay? So one way is to solve it. The other way, think this. What must x be for this to be 0? This is called zero product law, because anything times 0 is equal to 0. Okay? If a times b is 0, well, one of these things, a or b, must be 0. Complete the following by solving. So everything we've done so far, like looking at this one, that's what we've had. Right? This is what the answer was when we factored it. We didn't have an equal to 0. Now it's called an equation because there's an equal sign. Let's look at the first one. 8x is 0. 8x is equal to 0. What must x be here for this equation to work? And if we don't see it, then we solve it. How do I isolate for x? Divide by 8. Whatever you do to one side, do to the other side. What's 0 divided by anything? 0. Okay, check it. Substitute it. Put the 0 back in here. What's 8 times 0? It's equal to 0. Look at this one. 8. Can that equal 0? No, that doesn't make any sense. Look at this set of brackets. X plus 2. When does that equal 0? When x is -2. When is the third set, or second set of brackets? The second binomial, the third term. When is this equal to 0? When x is 7. Okay, we have two choices here. There's two solutions. If x is what? this thing will be equal to 0. Yeah. When x is 0. Okay. When x is -2, this will be equal to 0. When x is 7, this will be equal to 0. And if any of these are 0, then the equation works. Everything is equal to 0. Okay, a little tougher. What does x need to be here for this to be equal to 0? If you see it, great. And in a few days, we'll be getting pretty good with this. If we don't, we solve it. Okay, what does x need to be for this whole thing to be equal to 0? Because if this is equal to 0, I don't care what this is. The equation's going to work. Okay, -1 to both sides. 2x is -1. Divide 2 from both sides. X is by itself. X is -1/2. What about this guy? What does x need to be for this to be 0? Solve it. -2/3. Okay, that's my solution. Those are the only values of x that will make this equation work. Check it. If you substitute that back in here, this will work. It'll be equal to 0. If you substitute that back in here, let's just look at that one. 3 times x, if x is -2/3, okay, -2, is that equal to 0? 3 divided by 3, okay, I have -2 -2, that doesn't work. What did I do wrong? Oh, wow, geez, I have to add 2 to both sides here. That's silly. Okay, x is +2/3, or just 2/3. There. Now, 2. Take away 2, that is in fact equal to 0. Okay? Silly algebra mistake. But I hope I'm proving my point. Why do we need to check these? To see if they actually work. That can eliminate some of your mistakes, like mine. Okay, I can divide by 8 in these equations. Okay, 8's a constant. I can do that. Why can I not divide by x in this equation here? Let me clean it up a bit. Can I just go, let's divide both sides by x. X divided by x, it's gone. If I did that, I wouldn't have this value anymore, would I? I would lose that. The answer is, because I know x is 0, I'm going to have 0 divided by 0. I can't divide by 0. Okay? That might be an option for x. So you can't divide by x. Okay? Because it's a variable, it might be 0. Can't divide by 0. Okay, solving quadratic equations. That's what we've been doing. So far, they've all been factored for us. So we're just going to put together what we've done in the last few days and today's lesson. Now we have to factor it first. Okay, they're starting us off pretty easy. What two numbers multiply to 20 and add to -9, -5, and -4? Check them. Yes. Yes, they add to -9. Okay, they've already started this one for us. So factored, we have x minus 5 is equal to 0, or x minus 4 is equal to 0. Okay, what must x be for this to work? +5. 4. Those are the solutions. That's when this equation works. When x is 5, or x is 4. Or, written the other way, 5, 4. Okay, if I put 4 back in here, what do I have? 4 squared minus 36 plus 20. Is that equal to 0? Yes, it is. Okay, solve by using the zero product law. On a test, it might say just that. Solve. Okay, you got to know what to do. But remember, this test is going to be called factoring. Factoring is probably a good place to start. Okay, is that something special? Two terms? You got to think. Is that a difference of squares? X times x is x squared. 9 times 9 is 81, plus minus, and we're done. That's a difference of squares. When is this equal to 0? Now we have to solve it. Okay? When x is minus 9 or 9. Okay? Solved. That's the solution. Let's look at this guy. What can I take out of here? Can I make it a difference of squares? X squared minus 9 looks like a difference of squares. This is actually, I tricked myself up when I did this the first time. It's not that. I still have an x here. Okay? I want it to be a difference of squares. It kind of looks like it, but it's not. That's not a difference of squares. But wait a minute. I can take something else out of here, can't I? 10x, x minus 9. Okay, that's factored. Can I factor any more? Nope. What must x be here for this to be 0? If you're saying 0, great. But remember, we could divide both sides by 10 first, if you like. X times x minus 9 is still 0 divided by 10 is 0. We get the same thing. If x is 0, this whole thing's 0. If x is 9, this whole thing is 0. Those are my two solutions. Okay? Do I need to do this one? Well, let's actually look at this one. Okay? Here, again, can I take out a common factor? That's what you want to look at first. No. What multiplies to negative 10 times 3? What adds to negative 13? Okay. I know that multiplies to 30. Looks like it adds to 13. How do I make this work? If it multiplies, either that has to be negative, which doesn't work. That gives me negative 7. Or that has to be negative. That gives me positive 7. That can't get to 13, can it? Okay, I'm on the wrong track. Remember, there's more than one choices to multiply to 30. That's what works. Okay? So I'm going to split up minus 13x into minus 15x plus 2x. I still have minus 10. And remember, this is still equal to 0. Factor by grouping. What can I take out of the first two? 3x. This is what I have left. Check it. 3x squared. Yes. Minus 15x. Yes. What can I take out of the next two? Just 2. And what do I have left? Better be the same thing in the brackets, or I can't do anything else. Okay, finally, what's common to both of these two terms? X minus 5. What do you have left? 3x plus 2. Okay, and I got a little lazy. This is still equal to 0. All right, when is this going to be a solution? When x is 5, this will be 0. And are we getting better with this? What must x be here for this whole thing to equal 0? Negative 2/3. Again, if we don't see that, then we solve it. Okay? Minus 2/3. How does this one look any different? Does it equal 0? No, it equals minus 25. How can I make it look like this one? Because I just solved this one, I know what to do. How about I throw that to the other side? How about I add 25 to both sides? Ah, now it looks like something I want it to. Okay? I'm not going to do this one. It's pretty similar to one we just did, but what do you want to do first here? Make your life easier. Okay? Because I'd much rather factor x squared plus 6x plus 5 instead of 5x squared plus 30x plus 25. Right? That one I can do by inspection. Okay, problem solving. There's the English. Okay, here's a nice question. This is where we're actually going to visually see something that we can use to factor this stuff. I'm going to change this a bit, okay? The area of a triangular sheet of paper is 300 centimeters squared. 300 square centimeters, same thing. The height of a triangle is, this will be nicer if I put a 10 here, 10 centimeters more than width of a triangle. How about more than the base? Okay? Form a polynomial equation. We've been doing these for days, right? That's a polynomial equation. I don't know if it factors or not, but don't get confused. That's all we mean. And solve it to determine the, well, I could ask you to get perimeter of the triangle, but for our first one, let's be a little easier. To determine the base, okay? All we want to know is the base. There's a relationship between base and height of a triangle. I'm talking about the area. We want to start there. What is our formula for area of a triangle? I need to know my base. I need to know my height. My area is 1/2 base times height. Or, if you like, base times height over 2. Same thing. Okay? Here's an equation. The only way I can solve an equation, I got to know 2 of these 3 variables. Okay? I can only have one unknown. I can't solve this if I have 2 unknowns, unless I have another equation. So what do I know? I know the area is 300. Let's substitute that in there. 300 is base times height over 2. Okay? I can simplify this a bit. Let's get rid of the 2. Multiply both sides. 600 is base times height. To get the base, if I knew what the height was, I'd be done. I don't know what the height was, but the height is 10 centimeters more than the base. Let's write that. The height is 10 more than the base. Take the words, make it a math equation. Okay? Now I know what the height is. Substitute it in here. 600 is the base times the height. The height is 10 plus base. 10 more than the base. How does that help me? Well, now I only have one variable in my one equation. I should be able to solve this thing. Okay? Expand this out. Okay, so 600 is 10 times b, or b times 10, same thing, plus b squared. Okay, and just like that last question with the 25 on the other side, let's throw this to the side where everything else is, and I'll have 0 left. Okay, so I have 10b and b squared minus 600, and I don't want to see it in this form. Okay, I want to rewrite that b squared plus 10b minus 600 equals 0. And now we factor it. What 2 numbers multiply to negative 600 times 1 and add to 10? Okay, it's kind of big, kind of ugly. What multiplies to 6? 2 and 3. What if I put a 0 there? Well, that's positive 600. I need to get to positive 10, so the bigger one needs to be positive. Check it. Does it work? Yes, it does. Okay, b plus 30, whoops, b minus 20. That's my two numbers. Okay, so I'm doing this one by inspection. This is a 1 here. All right, factored. What's my solution? Solve. Well, what does b need to be for this to be 0? Negative 30. 20. Okay? So that's what we've been doing so far. Okay? Other than all the words and stuff, but we need to do one more thing. Use some common sense. What did I solve for? What is b? It's the base of my triangle. Okay? Does negative 30 make any sense? Can I have a negative length? It doesn't. Okay? And the wording is we need to reject this negative value, okay? Because base must be positive. Okay? It's a distance. It can't have a negative base. That doesn't make any sense. So the only number I have, the only solution in this case, because it's a practical question, is 20. Okay? Do I have a unit? Yes, I do. That's centimeters. Okay? That's the only answer here. 20 centimeters. Okay? Questions? 1 to 3, odds, and 5, 7, and 8.